Okay, let's give you guys some more practice. So solve this equation here. Solve for x, but x has to be within this range here. So if you get a graph plotter and plot y equals this whole thing here, you will get this this graph here. So this is your y-axis, this is your x-axis here. If you plot y equals this thing here, it will give you the red lines here, and you want this whole thing to equal 2. So if you look at 2, where's 2? 2 is here. Draw a horizontal line across. You see this here is a solution, this here is a solution, 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 and so on. But the thing is, you want the solution within 90 and 180. So you want it within this range here. Okay, so here you can see it's only this solution and this solution that we're interested in. That's within this range here. Okay, so well, when you're given this problem here, you're not going to be given the graph. So just use what you've got here and solve x. Okay, so press pause and have a go. Okay, so to do this here, visualize it as this. You've got one block here, plus 7 equals this block here. So kill off this 7. You're trying to get x on its own. You're trying to get this x on its own. So kill off the 7. So take away 7 from both sides. So this will be 3 tan 4x minus 180. And then remember, in your mind, you're taking away 7 from both sides, so that will be negative 5. Okay, and then and now visualize as this. You've got one block multiplying this whole thing here. So kill off this 3. So divide both sides by 3. So it will be tan 4x minus 180 equals negative 5 over 3. Okay, and now you could say that 4x minus 80 here equals well, inverse tan both sides, so that this will be this negative 5 over 3. So now you would jump to your calculator. So 4x minus 180. Well, jump to your calculator and punch this in. So calculator, negative, I'm just going to do 5 divided by 3 equals this. Stick a negative in front, and then inverse tan, and then it gives me, well, I'm going to round off to negative 59. So negative 59. So now you would jump to your don't forget this is in a bubble here. Okay, so at the moment you can imagine bubbled equals this thing here, but if you jump to your tan graph, so 90, 180, 270, 360 here. Whenever you sketch your tan graph, visualize the circle here. Remember, the tan is really the height. Well, tan is this thing here, so it's always the height divided by the width. Well, at 0 here, it would be, the height would be 0, the width would be 1. So this here would be 0. Okay, and then at this point here, the height would be 1, and then the width would be 0. Height is 1, and the width is 0. You see, this here, it breaks down, so you know you've got an asymptote here, and then you can use the same argument, and you will have another asymptote at 270. So when you come to draw your tan graph, try and visualize this circle here and identify the asymptote. Okay. Well, anyway, your graph will look something like this. Hang on. It will look something like this, and then you have another. Well, anyway, it's gonna be something like this. You have another asymptote somewhere up here, so it's gonna be something like this. Okay, and then here it will look something like this, and another asymptote but over here. Well, anyway, your tan graph will look like this. What we've got here is minus 59. So minus 59. Whenever you punch this into your calculator, the calculator will give you a solution within this range here. Okay, so well, in our case here, it's negative 59. So I'm going to guess negative 59 to be around here. Okay, so don't forget, if you add 360, you're going to get this bit here. Add 360, you're going to get another solution here. Bearing in mind that if you add 360, you're going to miss this solution here. This is also a solution. Okay, because we are trying to solve negative 5/3. Well, negative 5/3 on our diagram is around here. Okay. Well, anyway, this is our first solution here. If we add 360, that will give us this point here. Add another 360. That will only take care of half of the set of solutions. Okay. So, well, anyway, this whole thing here equals this plus 360 n. Okay. Remember, n is an integer, and then also we've got to stick an and in here, and don't forget we've got to somehow find this this thing here. Well, from here, all you need to do is add 180. That will take you to this point here. So we can say and. So this is our and here. Negative 59 plus multiples of 3. Hang on. Sorry. Hang on. It would be negative. Well, don't forget. Sorry, I made a mistake here earlier. Once we've got our solution here, we need to add 180 just to get to this solution here. Once we are at this solution here, then we can start adding multiples of 360. Okay. So if this is negative 59 here, all we need to do is add another 180. So that's like us doing, well, that's like this. Hang on. That's like negative 959 plus 180. But I'm just going to switch these two around here. Okay, so it will look like this. 180 add negative 59, but then I can take the minus out here. So this here becomes a minus. This here, this here will become a plus here. So in effect, it's going to be 180 take away 59. Okay, it's the same thing. Well, do whatever method you want to get to this solution here. So it will be this will be 7 1. So this will be a 1 2 1. So this point here is 1 2 1. Okay, that's us working this out here. 1 2 1. And then now all we have to do is add multiples of 360 n. Okay, where n, well, for all n belonging to the set of integers. Okay, so this is our this is halfway there. Don't forget. So now now we need to sort. Well, we need to sort out this x here. We need to somehow break into the x. So let's just look at our first set of solutions here. This is our first set here. Okay, so it will be 4x. Hang on, 4x minus 180 equals this. Well, we are just dealing with this set only for the time being. So minus 59 plus multiples of 360. So now add 180 to both sides. So this will be 4x here, and us adding 180. That's just like us doing this. 180 minus 59. Okay, but yeah, minus 59 here. So this would be a 7. This would be a 1. This would be a 1, and this here would be a 2 1. Also, it's just a coincidence that it equals this as well. Well, anyway, this will be 1 2 1 plus 360 n. Okay, now divide both sides by 4. So x equals 121 over 4 plus 90 plus 90n. Okay, so this is our second set of solutions here. So this is this here is our set of solutions for this first part here. Okay, now we need to take care of this one here. So this one here would be, well, start by writing this 4x minus 180. Hang on, 4x, start by writing 4x minus 180 equals, now look at this here, it's, remember we've just dealt with this, now we need to look at this, so it would be 121 plus multiples of 360, so 121 plus multiples of 360. Okay, so now it's just a matter of solving x. So add 180 to both sides. So this will give me 301 here plus 360n. Okay, so when you're here, add 180 to both sides. Okay, so that will give us 301. This here would be 4x. So now divide both sides by 4. So x equals 301 over 4 plus 90n. Okay, so we are making progress here. So this is our first set of solutions, and this is a second set of solutions. But now we need to take the range into account. We want x, so that x is between, what was it? Between, I need to go up and have a look. Hang on, between what? Hang on. X has to be in between 90 and 180. So 90 and 180. Hang on. So remember, this is our first. We are making progress here. This is our first set. This is our second set of solutions. And okay, let's just look at this one here. So this one here is saying 121 over 4. Hang on, 121 over 4 plus 90n. Okay, and then the second set here would be 301 over 4 plus multiples of 90. Now we've got to. So remember, if you choose any n and put it into here and here, it will give us a solution. But the thing is, we want solutions where they're in the range of 90 and 100. So let's guess. I'm going to guess this. I'm going to put n to be equals to 2. Okay, I'm going to put n equals 2. So I'm going to guess n equals 2. Let's see if n equals 2 is within our range here. So we are going to put n equals 2 into here. Okay, so this would be, hang on, this would be 121 over 4 plus, well, when you put 2 into this n here, it will be plus 180, plus 180. Let's see if this is within our range of what was it? Remember, we want it in the range of 90, where x in the range of 90 and 180. Well, looking at this here, if this is 180 and then you've got to plus an extra bit here, then this is out of range. So this, the overall thing here is no good. Okay, so let's put n 2 into this n here. So this will be 301. Well, n is this will be this here plus. Well, if you put 2 into this 90 here, it will be 180. 180. Again, this is out of range because this is beyond 180. Because I know that because this is 180, and then you've got to plus an extra bit here, so it's beyond it. So n equals 2 is no good. Let's have another guess. N equals 1. N equals 1. So when you put n equals 1 in here, when you put n equals 1 into here, then you will have this. Hang on. So this is one solution here. 121 over 4. That's this bit here. Plus, well, when you put 1 into this n here, it will be plus 90. You see, if this whole thing here is within our range, then it will be good. Now put 1 into this thing here. So this would be 301 over 4 plus 90 here. If this is within our range, then it would be good. So calculator here. let's work this out. Now looking at the one on the left hand side here, 121 divided by 4, and then plus 90. If this is within our range, then it's a good solution. Yeah, so this is within our range. Remember, our range is between here and here. 120 is in between, so this here is a good solution. Okay, so one solution would be 120.25. This here is a good solution. Okay, it's within our range. Now let's look at this one here. 301. Hang on, 30. Cancel this. 301 divided by 4. Is it 4? Yep, divided by 4 equals this, plus 90. If this is within our range, then it's a good solution. Yeah, it's within our range. So 165.25. This is a solution within our range here. And then if I were you, I would check for n equals 1. N equals 0 now, just to make sure there are no other solutions within our range. Yeah, so you can check that for yourself. But when I showed you the graph earlier, we noticed that there were only 2 solutions. So hang on, where's the graph? Hang on. So looking at this here, so the graph earlier was this here, in the range of 90 would be here and here. So we just solved those 2 points there. Okay. Yeah. So hang on. So well, 90 here and 180 here. So we just solved these 2 points here. Okay.